Today we are going to discuss about vector algebra. There are two types of quantities. One is scalar quantity and another is vector quantity. What is a scalar quantity? Scalar quantity means it contains only magnitude. For example, this pen. This pen is having length 10 cm and this is a scalar quantity. That means length is a scalar quantity. Mass, similarly area, similarly distance, and there are so many quantities which are scalar quantity. Now we will discuss about what is vector quantity. Vector quantity which contains both magnitude and direction. Suppose for example, displacement. Displacement is a vector quantity. For an example, what is displacement? यदि तुमको गोटे क्रिकेट खेलला बेलू गोटे बैट रे बॉल को मारिबार थाउछि तो यू विल किक द बॉल इन some direction, not haphazardly. Then there is a fixed direction and that ball also go to some distance, and this is what known as vector quantity, where there is a direction. Suppose you have to go from one place to another. There are so many ways, like one place to another. There are so many ways. This way, this way, this way, where you don't have to follow a direction. But if you want to know the shortest distance between these 2 points, then it is only in one direction, which is known as a vector quantity, and this is known as the displacement. So displacement is a vector quantity. Similarly, force is a vector quantity. Momentum is a vector quantity. So this is what known as scalar and vector quantity. Next we will discuss largely about vector algebra. Suppose this is a line segment and this is also a line segment. This have a direction and this also have a direction which is opposite to each other. These are known as directed lines. But suppose we draw it like this from A to B, and the direction is towards A to B, upward direction. A is known as the initial point and B is known as terminal point. So suppose now this is known as the AB vector, and this vector is directed A to B. These have two things. One is magnitude. Magnitude means distance from A to B, distance from A to B, which is equals to AB, which is always greater than 0. And another thing, it have direction, which is from A to B. Suppose the direction is from B to A. Suppose it's the opposite. We will discuss. Suppose this direction is B to A, then we will write it as BA vector. And if we want to relate between AB vector and BA vector, then AB vector is equals to minus BA vector, because magnitude is same, only directions are interchanged. That is all about what is a vector quantity, how it is represented as initial point, terminal point, and about the direction of a vector. Now we are going to discuss about position vector. What is a position vector? What is a position vector? Suppose this is x-axis and this is y-axis, and there is a point P known as x, y, z, and this is O, and this is the directed line from O to P, means from origin towards that point. Then this vector OP vector let it represent as r vector, is known as position vector of the point P. Suppose we discuss in three-dimensional geometry. Y, Z, this is the origin known as 0, 0, 0. There is a point, let it P, Q, R. Suppose it is a vector A vector, and this is a vector B vector, and let it C vector. These are the position vector from O to Q, but it is the position vector of the point Q. Point Q माने आम ये बुझान जे point Q माने गोटे point रो ही गोटे वेक्टर थिबो, because point रो केबे वेक्टर नथिबो, because a point have infinite of direction. So जेतेबेले आम position vector, when you want to understand, then this is the vector joining from the origin towards the given point. Suppose it is the point P, its position vector from O to P is OP vector, which is known as A vector. Like this. Suppose there are 2 points P and Q. 2 points. Now P having point x1, y1, z1, and Q having coordinates x2, y2, z2. Then we already discussed in our first semester 3-dimensional geometry, the distance between PQ is equals to x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square root, like this. Similarly, suppose we want to write it the OP vectors magnitude, and let P be the point x, y, z. Then it will be x minus 0 whole square, that means x square, y minus 0 whole square, y square, z minus 0 whole square, z square, and this is equals to root over. And this is what about position vector. If you want to know the position vector of a point and you have the coordinate of that point, then you have to represent it is from the origin towards the point P, and the direction is from origin towards that point P. This is what known as position vector. Next, we are going to discuss about direction ratios and direction cosines. What is direction ratios? And direction cosine. At first, we will going to discuss about this by the help of two-dimensional geometry. Not all vector is a 3D study, but it is not possible to show everything in 3D because we are working in a plane and 3D is a space. That's why we first discuss about by 2D. If it is a point x axis, and this is y axis, and there is a point P having coordinate x, y, and this is the direction, let it theta. It means the vector OP is making an angle theta with x axis. So here, what is theta? We already discussed in 2D, and if we draw, it means it is the direction from O to P. If we want to extend the P from up to this, then also this theta will not be changed. So this OP vector, in this OP vector, however with the magnitude, but direction will not be changed. And here, if we draw a point P and draw a perpendicular towards x-axis up to M, then this will be x0 and this quantity will be x, this quantity will be y. Now in 2D we are discussing about theta. Theta ro elevation kete x axis sangre. So theta is the elevation with x axis. Now we will want to know that this line OP ero x axis आडको कौन संपर्क अच्छे एवं केते की से लईकी अच्छे कितना झुकाव केते झुकी की अच्छे से जिनस आमे एठी जानबा जे OP जोटा अच्छे सेटा x axis संगरे तारो संपर्क को भले भाव रही एंड वी विल डिस्कस हियर about the tan theta which will be equal to your y by x. But in 3D, while we are going to discuss about direction ratio and cosines, what will happen there? In 3-dimensional geometry, this is x, this is y, this is z, and this is the origin 0, 0, 0. And if there is a point P is a point in the space, but we can't draw it here. That's why I will draw the point P here, x, y, z. Now the OP vector having direction from O2 towards P. And if this is the angle theta, I can't write it that this is theta because this makes an angle with x-axis, an angle with y-axis, an angle with z-axis. In 2D, we will only discuss about the angle with x-axis, not y. But here in vector, we will discuss all things about the angle with x-axis, y-axis and z-axis. So this direction have angle with x, y, z and having relations with x-axis, y-axis and z-axis. So if this point P is here, not here, but I am drawing it here. Now this OP vector makes an angle with positive x-axis, let it alpha. Next OP vector makes an angle with positive y-axis beta, and OP vector making an angle with positive z-axis is gamma. Now what will be the relation? Here we will calculate tan theta, but here we have to calculate it for x-axis, y-axis and z-axis. Not कि यार x axis आडो को ही केते तारो कौन रिलेशन अच्छे जिनसे नहीं यार हमको तीनटा जगह x axis संग काढ़े अच्छे. That's why OP vector x axis संग रे alpha angle, OP vector y axis is so beta angle, and OP vector makes gamma angle with positive z-axis. Then how will we discuss? I will discuss it in, you draw it in 2D. Suppose x and this is P, x, y, z. This will be O. This will be the direction OP, and if it is alpha, if it is x-axis, and if the angle makes with OP vector makes an angle x-axis alpha, and if we draw a perpendicular from P to M, then this will be let it R vector because we have to find the relation between OP vector, and here OP vector works. That's why let it be R vector, and this is X because if you draw the perpendicular PM, then from the drawing we can conclude that this will be your X. And now we will have to calculate about direction cosines. We can write direction cosines as like this. So direction cosines here, cos alpha is equals to X by R. Similarly, cos beta will be equals to y by r. Similarly, cos gamma is equals to z by r. Here we represent cos alpha, cos beta and cos gamma as L M and N, which is known as direction cosines of this line OP vector here, OP vector. Now, what will be the relation? X is equals to R cos alpha, Y is equals to R cos beta, and Z is equals to R cos gamma. From here, if we take it as R vector, then R vector magnitude, it means R, which will be equals to your x square plus y square plus z square root over, what is x here? R square cos square alpha plus R square sin square alpha plus R square cos square beta and R square cos square gamma root over. Like this, you can take R square common, cos square alpha plus cos square beta plus cos square gamma root over. This is equals to R root over of cos alpha is L, cos beta is M, and cos gamma is N square. This is equals to R. R cancels to each other, and 1 is equals to L square plus M square plus N square. So the relation of the L, M, N means direction cosines of any vector is L square plus M square plus N square is equals to 1. This is direction cosines, which is written as sometimes like DCS, direction cosines. Now we will discuss about direction ratios. Where we discuss about cos alpha, cos beta and cos gamma, which are always a rational quantity, and when we calculate it in doing some problems, then we can face some problematic things, and maybe we can't get good answers. That's why we are going to introduce another quantities which are known as direction ratios, or known as DRS, direction ratios. Direction ratio means what? Let A, B, C are direction ratios proportional to direction cosines. It means L by A is equals to M by B is equals to N by C is equals to lambda. Then here L is equals to A lambda, M is equals to B lambda, and N is equals to C lambda. But we know L square plus M square plus N square is equals to 1. That's why lambda square A square plus lambda square B square plus lambda square C square is equals to 1. So taking common, lambda square A square plus B square plus C square is equals to 1. Now lambda square is equals to 1 by A square plus B square plus C square. Lambda is equals to 1 by plus or minus A square plus B square plus C square. So L is equals to A lambda, it means L is equals to A by plus or minus root over A square plus B square plus C square root over. Similarly, M is equals to B by plus or minus A square plus B square plus C square root over, and N is equals to C by plus or minus root over of A square plus B square plus C square. So it is the relation between the direction cosines and direction ratios. Now it is all about direction cosines and direction ratio. Next, we'll discuss about types of vector. Before discussing about types of vector, in this chapter we are discussing about free vectors. What is free vectors? Free vector means they are free, not they are not bounded. We can join any two vector like this, means they don't have any restriction. But in higher classes you will read about non-free vectors which have some restriction. So with this we'll start about different types of vector. First one is your null vector. What is null vector? Null vector is also known as zero vector. What is null vector? A vector whose initial point and terminal point are coincide. A vector whose initial point and terminal point are coincide is known as null vector or zero vector. And its magnitude, because it is only a point, because its initial point and terminal point are equal, so it is only a point. If it is only a point, then there is no direction, or we can't say there is no direction. We will say that it cannot assign any definite direction. Okay, it cannot assign any definite direction. That means magnitude of this null vector is 0, and we can represent as a vector because the initial point and terminal point is equal 0. It cannot assign a definite direction. Then we'll discuss about unit vector. From the name we can imagine the definition of this vector. A vector whose magnitude is 1 unit and direction is same as that of given vector is known as unit vector. And how we can represent is, if A is a vector, then because it have only magnitude, only direction, it have only one magnitude and only direction. So this is important is to know the direction. So a vector, if we have to know the unit vector of a vector, then we'll divide it by its magnitude and it will be represented as a kf. So it is a unit vector and the direction of a kf is same as that of direction of a vector. That means when we discuss about x, y and z, if it is a vector, there is a point p, q and r, and if o is the origin, op is a unit vector, then op is a unit vector, then it is 1 0 0, p have a point and q have a point 0 1 0, r is a point 0 0 1, and the and op vector is represented as I cap, oq vector represented as j cap, and o r vector is known as k cap. So the unit vector in the direction of ox x-axis is I cap, y-axis is j cap, and z-axis is k cap. This is what about the unit vector. Now we're going to discuss about co-initial vector. Two or more vector said to be co-initial vector when they have same initial point. Suppose we are going to discuss in a, let it is a parallelogram O, A, B and C. This is A vector, this is B vector, this is C vector. A vector and B vector have same initial point. So these two are collinear vector. A vector and B vector is co-initial vector, because the initial point of OA vector and OC vector is O. That's why this is a co-initial vector. Now we'll discuss about collinear vector. Two or more vectors are said to be collinear if they are parallel to the same line segment, irrespective of their magnitude and direction. Two vectors or more are collinear if they are parallel to same line segment, irrespective of magnitude and direction. AB vector, BC vector, and we can, if it is A vector and it is AC vector is some B vector, we can write it as A vector is equals to lambda B vector. So it is a collinear vector. If lambda is positive and lambda may be negative, if lambda is positive then they are known as like vector, and lambda is negative then they are known as unlike vector. These are the types of vector. With this class is over, and we'll discuss some more things about vector in our next classes.